ARM v9, version 9A to be specific. The next generation instruction set for ARM processors has been announced, and it's caused some confusion in the Apple community. I think mainly from people just reading Andre's article at AnandTech and assuming all of those generics would also apply to Apple in the specific, and wow, does Apple just not work that way. So let's clear things up. Sponsored by Brilliant. It's important to be just 100% crystal clear that Apple no longer has a design license with ARM. I mean, they did back in the day for the A4 and the A5 and the ARM Cortex cores.
Which means that you have the right to buy and sell these chips and in some capacity configure them differently, but it's still the exact same ARM core that everyone else uses in that license.
But ever since the A6, they've had an instruction set architecture, an ISA license.
So these are companies who pay for the instruction set and design their own architectures. Apple is one of those. Samsung is one of those. NVIDIA is one of those. Broadcom is one of those. There's a list of 10 to 11 architectural licensees. So Apple has a license for the instruction set, which then allows them to create a core that no one else uses, is differentiated from everyone else's core, and it's entirely proprietary to themselves. So there's a nitty gritty here. Like, so what happens if NVIDIA buys ARM? Is Apple screwed, right? The reality is no, because Apple has the instruction set. They can do whatever they want.
And also, it is specific to the CPU cores. I know a lot of people like to say things like Apple is switching from Intel to ARM, but that's not really an informed statement or an accurate statement.
The design of it themselves is entirely proprietary. And so anything ARM does, anything any competitor does with ARM and chips, like it's hard to compare those two things, to be honest with you, because Apple's really designing so much of their own process and architecture. Like, it's called ARM only because it runs on the instruction set, but it's very different than a lot of the other ARM processors out there.
Apple was switching from the x86 architecture and Intel CPUs, along with Intel integrated GPUs, AMD GPUs, a whole computer smorgasbord on a board, to their own custom architecture that just happened to use the ARM instruction set for just the CPU part. And while that is a critical component, it is only one small part of what Apple is doing with their custom silicon.
I mean, the GPU is becoming much more custom, which has nothing to do with ARM's GPU called Mali. They're not using any of that. There are elements of, like you said, the Swift code, even their machine learning process, the neural processor, right? And they bring out all of those sub bits for software or an SDK.
Apple was originally using the ARM v7 instruction set, but they went to ARM v8 with the iPhone 5S in 2013. And that gave them several things like the secure enclave, but also 64-bit. And a lot of people sort of played that down at the time, saying you didn't need 64 bits to address large amounts of RAM in a mobile device. It didn't make any sense. But it gave Apple the cleaner instruction set that was ARM v8, but it also served as a jumping off point for Apple to reset their architecture, to begin the scalable architecture that they've been iterating on ever since, sort of the special sauce that's made Apple's silicon so special over the years. Now, that wasn't entirely due to ARM v8. That just happened to be at the same time as ARM v8. And that's something we also need to keep in mind when it comes to ARM v9. We'll get to what it actually might mean for Apple in a red hot minute. But first, if you're at all worried about compatibility, Apple just has that handled at this point. I mean, they went from 32-bit to 64-bit on the Apple Watch pretty much transparently. And ARM v9 is backwards compatible with ARM v8. And Apple has things like bitcode on the App Store, which means that when you download apps, they identify the system on a chip you're downloading them to, and they optimize it for that system on a chip already.
Yeah, 100%. I don't think anyone will notice. This speaks back to them having the SDKs themselves, tying the SDKs to those unique hardware bits that they have. And Apple addresses a lot of those in software in terms of compatibility.
And I know some people were asking why Apple didn't wait on v9 before they released the M1. It was so close together. Even if you count some implementation time, why didn't M1 wait and debut with that? And my only gut feeling is that they didn't need to. Like, they could achieve everything that they wanted and needed to for the M1 using their current platform, their current architecture. And when people look at it and say, well, a v9 is going to give 30% increase over the next couple of years, I think that's entirely covered in Apple's roadmap already. I don't think there's anything that brings that Apple wouldn't just grab for themselves.
It wasn't necessary for the product line. I would agree with that assessment. And so now it comes back to absolutely they're planning these things. And I mean, the thing that they again have an interesting advantage on is that they know what the perf gains will be for ARM over their roadmap, and they can actually tie that to TSMC's perf gains as it goes from 7 to 5. Like if you look at the performance of iPhone over a 4-year time frame in terms of what Apple's saying year over year they're getting in perf benefits, they are almost getting 100% performance increases over 4 years. It's just shy of that, about 90-ish%, right? So every 4 years, an iPhone is getting 100% more performance, right? It's just wild to think about how the steady gains of that benefit your refresh cycle, like the experience you're going to feel with a device over 3 or 4 years, if that's how long you're delaying.
So then what does ARM v9a bring to the table? And one of the big things for ARM v9a is confidential compute architecture, which introduces this concept of containers called realms. And those isolate execution environments from operating systems and hypervisors. And it's just a way to further harden systems. And this is something increasingly just everyone has to think about, from the silicon all the way through the software. I mean, Apple has recently introduced things like Blastdoor, which dramatically increases the security of iMessage payloads, and they're doing that from the software down to their custom silicon. There's also Scalable Vector Extensions 2, or SVE2, which finally fully replaces the old fixed Neon instruction set with an improved dynamic instruction set that can scale beyond 128-bit registers to, theoretically, 248-bit registers at some point for supercomputers in the future. And that just makes it way easier to scale things like machine learning, digital signal processing, from accessories, Internet of Things, to wearables, to mobile, to desktop, to server, and everything between and beyond. And this is, again, something that we've already seen Apple do, not just working around Neon in general, but adding things like neural engine cores in increasing amounts, adding machine learning accelerators right to the CPU, having a machine learning controller that can move tasks between the neural engine, the CPU machine learning blocks, and the GPU. So it's mainly those things: security, machine learning, scalability, and sort of post-CPU compute, which, if those sound to you like all the things that Apple has not only been addressing, but really leading the way, trailblazing in over the last decade or so, I think that's exactly the point.
I mean, there's been no better company at miniaturizing semiconductors and semiconductor processes than Apple, right? I think the watch is a great first step. I mean, that's the most complex sort of packaged board on one chip and board that you've seen. They'll obviously do that with other devices. These, even AirPods Pro, et cetera. These are tiny devices. And the reality is, Apple, I think, has had a lead in miniaturizing their designs, miniaturizing their semiconductor process and their overall architecture so that they've got efficient things that fit into small devices. ARM has to recognize that, right? I mean, the reality is Apple can't be the only one making small computers. So they want to enable their partners like Qualcomm and others to go and make these really great, small, yet powerful processes.
That's why, to me personally at least, and please tell me in the comments if you think I'm just dead wrong about this, but why, to me personally, ARM v9 feels a lot less like something that will give Apple another leap forward and more like ARM leaping to where Apple has been going all this time, sort of catching up.
I think it's an astute observation because, one, Apple's been, I think, setting some of the standards for how we think about elements of computing, right? So it doesn't shock me that either one, others will follow suit in terms of design, or two, that ARM itself takes some of that influence in those designs and applies them, because Apple's actually doing really smart stuff. And not that there's an IP exchange. Apple is under no license pretense to give ARM back IP, as other customers actually are. But I do think there's a knowledge share. I mean, ARM is obviously astutely aware of what Apple's doing and wanting to bring some of those best practices to the architecture.
And sure, there probably are some things that Apple is going to want to implement on ARM v9 and maybe even continue to influence as we get to ARM v9b, c, d, and on throughout the next few years. But it feels increasingly like Apple is charting their own path here. They're no longer bound to ARM, and they will just keep making the instruction set architecture increasingly Apple over the years.
Apple has their own architecture that they're designing for everything from notebooks to wearables to if they do something in a car, they're going to design it, etc. So they aren't using what you'll just consider the same types of blocks that ARM makes that other licensees have. They have an entirely unique process and architecture to themselves that's obviously highly differentiated. And it's not something that many companies can actually do.
I mean, do I think Apple's going to announce Swift ISA any day now? No, but would I be shocked if they announced it at some point? Also no. And this stuff is just so incredibly fascinating to get more and more involved with all the technologies behind it, or at least get started with everything from algorithms to neural networks and machine learning, math, science, computer science, logic and deduction, physics, quantum mechanics, game theory, cryptocurrency. Check out Brilliant. It's a website and an app built on learning while doing and solving real challenges in real time, with no memorizing long, messy formulas or fact sheets, no tests, no grades, just instant feedback that coaches you bit by bit so you can rapidly improve and learn fundamental concepts, literally before you even realize it. Just go to brilliant.org/Rene Ritchie or click the link in the description. Pick a course and get started now. Today. And clicking on that link really helps out the channel. Hit the playlist above for a much, much deeper dive into Apple Silicon and the M1. Just everything Apple's doing to achieve so much performance and efficiency. Just hit that playlist, and I'll see you in the next video.